Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Nvidia. We have Sumit Gupta. He is the general manager of the Tesla business unit. So, Sumit, welcome to the show, and why don't we just jump into it with the slides, and we'll do Q&A after that.
All right, sounds good. So, Rich, we have many exciting things happening this week at the GPU Technology Conference. I wanted to highlight three big ones. And I'll talk about one announcement that we're making in our core high-performance computing market. But then today I want to spend a lot of time to show you how GPU accelerators are being used beyond HPC, in particular in big data analytics, and also how the developer ecosystem is expanding dramatically with a new compiler for CUDA Python. So let's first talk about the HPC announcement. The Swiss National Supercomputing Center, CSCS, is announcing that they're going to build Europe's fastest GPU supercomputer. This will be north of a petaflop, and this is a Cray XC30, their new Cascade system with Intel Sandy Bridge CPUs, and Nvidia Tesla K20X, the Kepler GPUs. So we're really looking forward to this. It should be done by early next year, maybe even as early as late this year. CSCS does research in a number of topics, the usual suspects. It is a part of ETH Zurich. So you have astrophysics, climate and weather, genomics, geophysics, and material science. I do want to highlight one of the really interesting case studies out of CSCS where they've been working with Matteo Swiss on improving weather prediction. So they have a weather model called Cosmo, and they've come up with some interesting algorithms that improve the accuracy, in particular for higher resolution, which means so the problem in Switzerland, or the uniqueness of Switzerland, is it's a geography with many small microclimates. You have small towns nestled in between the Alps, and so they want to do weather prediction within these small towns. And Cosmo can do this, and what GPUs provide here is a 3 times acceleration in many of the key kernels that enable Cosmo to run this way. So this was kind of the core HPC announcement, but let's look at what GPUs are doing outside high-performance computing, or I should say in adjacent markets. In particular, I want to focus on big data analytics today. And so GPUs have a lot of applicability in different big data analytics problems. I'll highlight 4 unique and very diverse use cases just to show you first of all, the use cases and the momentum GPUs have here. The first one comes from Salesforce.com. It turns out that Salesforce.com is one of 6 companies that has access to the Twitter fire hose. The Twitter fire hose is all tweets happening at any time. It turns out there are 500 million tweets happening per day now. So it's just, the numbers are mind-boggling. And Salesforce.com has a new, relatively new, marketing cloud business unit, and they provide analytics services to corporations. So for example, Gatorade wants to look at the Twitter feeds and figure out what athletes are saying, what their fans are saying, and associate their brand with these fans and with these athletes. So, they constantly want to be analyzing Twitter and be engaged there. So they use Salesforce.com's software to do this Twitter analysis. The challenge is, and what they do is they put in a number of text searches. Many times the expressions can have 100 keywords, maybe 1,000 keywords. And Salesforce.com software analyzes Twitter and gives them back these results. So far, while they were using CPUs, it used to take 10 minutes to do this text search. They've now moved to a GPU-based system, which gives them almost real-time results. In Twitterland, 10 minutes is yesterday's news, right? Engagement means you should be on it as soon as it happens. So this ability to get almost real-time search is really helps the brands like Gatorade, Cisco, Dell, other customers of Salesforce.com engage in the social media discussions. So this was Salesforce. Then the second example comes from Shazam. I don't know if you've used Shazam, but essentially this is a mobile app that if you hear a tune, it can recognize what the tune is, and in fact you can buy it right there and then. In fact, yesterday we were driving in the car and my wife said, "Hey, isn't this Black Eyed Peas?" I said, "No, it's not." And then we Shazammed it. It turned out it was will.i.am, so she did recognize him, and we figured out which song it was. So Shazam is getting tremendous growth. In the last 1 year, the number of user searches has tripled, and their database of audio tracks has also tripled. They're adding new tracks, millions at a time. They do a deal with some label or something, and they add those tracks in. They're expanding to advertisements on TV. So if there's an ad playing, they can actually recognize the ad. You can Shazam an ad just by the jingle in the ad. So they can provide commercial services to companies. Shazam has started using GPUs. So if you do an audio search on Shazam now, it's running on Nvidia's Tesla GPUs in a data center. So in fact, I yesterday when we Shazammed it, I proudly told my wife, that just ran on my product. It's the dramatic growth means that they have to be able to scale their data center to be able to handle these increased searches, and that's the reason why they've turned to GPUs. GPUs accelerate the search, they accelerate the sort of fingerprinting of audio tracks and the matching of those fingerprints, and they allow them to scale their data center as the volume of searches and the volume of their database grows. Right? So this is yet another example of how GPUs are being used, where the amount of data is tremendous and the number of users is tremendous. So the third example comes from a company called Cortexica. What they do is they do visual shopping. So, again, I'm going to use my wife as another example here. We go out shopping and she sees a bag or a shoe and she says she loves it, but how expensive is that? So, she's always looking for something similar, which is better priced. This app allows you to take a picture of a shirt that you like, and it matches it across the database of e-tailers, right? And gets you returns all these shirts which look similar. And the way it does this is it's more pattern matching rather than kind of character recognition. So it's more of a biologically inspired algorithm. So they're able to return patterns which are similar, and they're not trying to do an exact match, right? And this really allows you to say, hey, I want a shirt that looks like this. And for example, you may see something in a catalog, right, or a magazine that you're reading, and just take a picture and be able to get the results. As the number of users they have grows dramatically and the database that they have grows dramatically, they need GPUs to be able to accelerate these searches and matches and be able to give you results in almost real time, because that defines the user experience. Again, it's a very similar process. They essentially, every picture, they identify 500 to 1,000 key points. It's like taking a fingerprint and matching it across a database. And this is they've advanced the computer vision algorithms to be able to do this. It's always something very hard to do. And the fourth story comes from the video world. So turns out, I don't know if you're a fan of sports, but if you use ESPN Score Center on your phone, all the video in Score Center has been transcoded using GPUs or GPU-based servers. So a company called Elemental Technologies has a full video transcoding solution that includes a server and software, and that server has NVIDIA's GPUs in it. Weather Channel app, the ESPN app, HBO's app, the HBO Go app, all of these apps are using Elemental systems to take video and transcode it. And the challenge for them is, for example, Weather Channel during Hurricane Sandy had 12 million live video streams. And you had to transcode all of these into different sizes and resolutions, because you had people watching them on different phones, different tablets, different TVs, right? And that's where Elemental's technology came in. They could, with the help of GPUs, accelerate the video transcoding so that they were processing 3 times more streams, live streams, using the same hardware. So it's a net hardware saving, net power saving, right? I mean, in every way, it allows these service providers to provide service at a much lower cost. So 4 different stories. The stories range from Twitter analysis to audio search to computer vision or image matching, and lastly video transcoding and analytics. So very diverse, but all of them have a common theme, which is the amount of data that they're processing is growing exponentially, and the number of user queries is also growing, right? So combined, this growth in data and data sifting is growing extremely fast. Kind of demonstrate how GPUs can help in a very diverse range of big data analytics. So let's move to the third section. We talked about HPC, we talked about big data analytics, but the core of our GPU accelerator story has always been developers. I think the thing that we nailed right, or I should say we got right from day one, was when we put out our GPU accelerators, we also put out a C toolkit, the CUDA C toolkit. We expanded that over the years to include Fortran and C++, and today we're announcing Python. So now Python developers can have a native compiler that takes Python and maps it to a Nvidia CUDA GPU. So this was announced this morning, and the reason why Python is extremely important is it turns out it's one of the most popular languages, in particular among new developers. And the reason for this is Python is very easy to learn. It's a high-level scripting language with very powerful libraries, and it allows you to prototype your algorithm without having to worry about the programming aspects. And most developers, so I talked to Vijay, we heard from Vijay Pandey at Stanford, and he said, look, my developers prototype all our algorithms in Python, and then we translate them into C and C++ once we're done to get the performance. Now with this CUDA Python compiler, you can get the productivity of Python and get the performance of the GPU. This compiler comes from Continuum Analytics, who has a offering where this compiler comes from. So it's a third-party compiler. It turns out a lot of high-performance computing and data analytics folks have been using Python because of its productivity benefit. Do you want to pause and just ask them to?
It'll be fine. This microphone doesn't.
Okay, it kills them.
Only picks up closeness. Sorry.
No, it's good.
Okay, so good.
So the last bit of news I wanted to share with you is actually what's been happening on the education front. So once we had the CUDA software out there, we also went out and made an effort to actually get more and more people trained on parallel programming. One of the flagship courses for this was the course at University of Illinois Urbana-Champaign, when Mehu and David Kirk from Nvidia presented this course, established this course, and from that course material came hundreds of university courses all over the world. But in the last 5 years, we've been able to track about 50,000 students who've got trained on CUDA using these conventional classroom courses or workshops we may have done, or about maybe even webinars. About 5 or 6 months ago, 2 online courses came on online. Two online courses were established, and these are in the new massively open online courses, or MOOCs, from Coursera and Udacity. These are Introduction to Parallel Programming with GPUs, and these courses have already got 50,000 students registered in just 5 months in 127 countries. The reach of these courses, because of the convenience of being able to pick up your laptop, learn it at your own pace, do the classes and the courses at your own pace, is tremendous. And the other value is, if you're a developer already in the industry, right, you're not at a university, it's much more convenient to learn in the evening at your own pace on your computer. These courses offer you the ability to do your exercises on a cloud, so it's actually running on GPUs in the cloud somewhere. They allow all this easy development and testing and all that stuff through an online forum. The online forums that are connected to these are extremely active with lots of questions, lots of interaction among the students and the teachers and some Nvidia folks. So we really see these two things as being big additions, the Python and the online courses, in terms of expanding the reach of GPU accelerators well beyond HPC. Python is estimated to have between 3 to 5 million developers, and about 10% of those are expected, between 500,000 to 1 million are expected to be in the HPC or the data analytics kind of developers. So just if you look at the number of people who can now use GPUs much more easily with a high-level language like Python, it's grown dramatically. So those are the three big things we want to talk to you about today: HPC, big data analytics, and developers.
So Sumit, thank you for that. I really wanted to comment on this Python thing. I think this is big because I've posted a number of videos and stories about Python, and the hits go through the roof. Mm-hmm. I'm talking like a video about Python, just a presentation, will get 5x what I normally get on an HPC talk.
Wow.
Yeah. So that tells me exactly what you said, that there's this massive amount of people out there that are interested in this, and it's good for me because it attracts
that
viewers.
Actually jives well with our observations too.
Yeah.
When we first released the CUDA C toolkit, one of the early wrappers that came on top of CUDA was this wrapper called PyCUDA. This was a guy called Andreas. I'll mispronounce his last name, so I won't take it. Yeah. But Andreas built PyCUDA because he was a Python developer. He really liked the speed up that GPUs provided, but it wasn't a full-fledged compiler. What Continuum Analytics software provides is this full compiler capability for all Python developers.
Okay, and a little bit about them, because I hadn't heard that name before. What's their core business? Is it compiler technologies, or is it broader than that?
They're a software. They're a software development solutions provider, right? So this is one of the offerings in their complete portfolio, but they are a startup, right? So they're relatively new, but they have a complete offering around Python. That's where they're focused a lot on. But it's a complete integrated development environment, including the ability to develop using their cloud-based tools.
Okay. Well, I wanted to go back and talk about the Swiss system, because I just came back from Lugano, as you did.
I
you were
was there 2 weeks ago.
Before me.
Yeah.
And I'm sure they were dying to tell me about this, but it wasn't announced at that time. What is that? No, it's named after a peak, is it not, in the Alps?
Yes.
How do you say that?
You're going to catch it. I think the only people who can pronounce it right are the Swiss. It's the Daint.
Daint. Okay.
You probably pronounced it better than I did. In fact, if you look at the picture here, that is a rendering of what the peak and the system will look like in the Cray cabinets. And as you and I have both seen, Lugano is surrounded by these beautiful mountains. So.
Yeah. So this will be over a petaflop system, the biggest GPU accelerated system in Europe.
That's right.
Oh, terrific! And they've been, of course, they've been doing that kind of computing for a while now, so they should be able to utilize that.
Well, they have. So that's a very good point. So CSCS, ETH Zurich have been very methodical in how they have adopted GPU accelerators. For the last several years, they have slowly but surely accelerated their applications with GPUs and proven to themselves that a GPU-based system is how they can get the next level of acceleration for all their applications. So they've really built a community around these accelerated computing solutions before going and investing in the hardware.
That's terrific. So I guess before we wrap up here, you've kind of spent a broad base of how you're building your business, and we haven't really talked about the business part of it. How's it going? I mean, Kepler came out, you fully announced the 64-bit version, the K2, at the Supercomputing conference in November. What's happened since?
It's actually been just an amazing uptake. I think the one thing is very clear to everyone we talk to in high-performance computing, which is that accelerated computing is the path forward. With Intel announcing Xeon Phi and Nvidia being in this market for now 5-6 years, there's no other solution, right? If you want to do HPC, you have to use accelerators. Also, I think the community has realized that the way to program all these accelerators is the same. If you want to do high-level programming, then you use a directive-based approach like OpenACC. If you want to do explicit parallel programming, you use a toolkit like CUDA. The one thing I didn't mention about CUDA Python is Continuum Analytics actually used the open source LLVM project into which we had contributed the CUDA compiler. So that effort that we did about a year ago is bearing fruition in these new compilers now. Right, so I think from that perspective, CUDA has become a much more open platform where anyone can build a new compiler or new language support because the compiler infrastructure exists, and also build a new backend to other platforms.
Well, terrific. Well, Sumit, I want to thank you for coming on the show today.
Thank you.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.